So welcome to the class. We're going to get stuck into the residential component of this topic. So first up, in regards to the assignment, we've got task 1. I've provided here a PDF of the assignment document. What we're asked to do, so for our task requirements, we've got, well, first up, the completion date, so due date the 30th of March this month. So we've got a shade under a month to do that, a little bit over 3 weeks. So it'll be due on the Friday, 5 o'clock, in about 3 weeks' time. Please let me know how you're tracking with that. I like to keep the due dates fairly far forward, so we're not cramming everything up at the end. And also a word about the assignments. Assignment 2 and assignment 3, you'll find they're not up on Moodle yet, but their structure is very similar to assignment number 1, where you have to provide a report based around this structure that I'll go through now. So for this task, you are required to provide a report employing appropriate construction and design terminology, comparing and evaluating 3 structural options, 3 cladding options, and at least 2 service options for a residential dwelling. The proposed building is on the learn site. And I'll go back to that proposed building in a minute. Actually, no, I'll open up a separate page here for learn. I'll get 2 going so we can flip between the 2. That'll be a bit easier. So within residential dwelling, we've got task 1, and then we've also got task 1 house drawings. So what we're asked to do is to reimagine this building as a permanent structure. So currently it is designed as a very simple, transportable, lightweight framing house. So designed as a transportable, so to be placed on timber stumps. What the client wants is they want this design, but they want that translated into a permanent structure. So what makes a permanent structure? Well, it gives us options. Yes, we can do lightweight framing and lightweight cladding as a permanent structure, either on stumps still, or we can do it on a concrete slab or brick piers. We can also reinvent this house as solid masonry construction. We can reinvent the house as brick veneer construction. We can reinvent the house as Hebel construction, like rendered Hebel construction. We can employ concrete tiles on the roof instead of lightweight sheet roof. We can, if so wanted, we could employ a hipped roof on here rather than the gable ends that we've got. We could do it as a truss roof, as a pitched roof. We could even do it as steel portal frame construction if we wish. Now, steel portal frame, that is the type of construction which is typically used for sheds, whereby, has everybody seen some prefabricated steel sheds before and looked at the type of framing that's used in there? I've got a few nods happening. So next time, if you're driving past Strathclyde South Road or so, you can have a quick look in there at their cold rolled steel section portal frame type sheds. That just refers to the independent frames. So if I do a cross section through a portal frame shed, so I've got in elevation, typically you've got your shed like this. Stratcos will do a maximum of 30-degree pitch on their shed roofs. That's about the max there. So that's our shed here, and we've got typically vertical sheeting on that. And let's say it's a gable end like that. The reason we have typical vertical sheeting on that is because we have our wall girts which run sideways between our portal frames. But if we were to slice straight through that shed, looking in the same fashion, we would see that we have steel sections like this. Well, that's a bit wonky, sorry. Have steel sections like that with knee joints on those steel sections, and then we'd have our wall girts attached on the outside. That's what I'm referring to when I say steel frame portal construction. And we'll get into that, into the design of steel frame portal construction later on. But if so wished, we could reimagine this house as a steel frame portal frame construction, if we wish. It's possible. So what the assignment asks us to do is provide 3 structural options. So 3 structural options for the house, 3 cladding options for the house, and at least 2 service options. And you just to read through pretty much what I've just explained. The current design is of a transportable timber frame building with timber cladding. The client would like to reconsider the design as a permanent structure. I've added this note: include where pertinent manufacturer's details for installation of your chosen options. So typically, if we look at a product, let's say we look at aerated concrete or Hebel as the brand name, what the common brand name for it in Australia is. When we go on the Hebel website, they will include both CAD blocks and PDFs of installation instructions or installation details. That will show how that Hebel is to be fixed to battens, how those battens are to be fixed and arranged to our studs, how we deal with corners, etc. So all those details are on their website. If you were to give one of the cladding options as Hebel construction, then grab those details, and where you make reference of this is how it should be installed, put those details in. So grab them from the manufacturer's product literature on their website and put those into the report. And I think typically it's best to choose smaller diagrams or grab the pertinent details and provide them within the report, as opposed to just grabbing the whole product literature and putting it as an appendix to the report. Smaller pertinent details within the report is much better. So you must include a reference list of all the websites, manufacturers' guides and other sources of information at the end of the project. So please keep track of where you've sourced your information from. So that can be fairly simple. Keep a Word document open for your list of websites. When you decide, okay, yeah, I want to use this one, I'm grabbing stuff from there, grab the URL, place it in your Word document for your reference at the end of your report.
Is there an example of how you set it out?
No, I haven't grabbed any other students, but what I will do is I'll go through basically the structure, sort of the skeleton of it, up here, and so that should give you a good idea. Although, yeah, and for those across the room there, what Levi was asking about is, do I have an example of the structure of the report? I don't have an example to give you, but what we have within the assignment literature is basically a list of how we can go about setting out the report anyhow, and this assignment literature will be a good guide for it. So, structure, research and evaluate 3 residential structural systems. Sorry for the dyslexia there. 3 structural systems for the roof, walls and floor. So
that's 3 for each?
That's 3 for each.
Right.
So 3 structural systems for the roof. Our 3 structural systems, and there are many, but it could include steel framed trusses, could include timber frame trusses, could include conventionally pitched timber frame roofing.
When you say structural,
Yeah.
are you talking actually about the cladding, or are you actually talking about the framework?
The framework, so the underlying structure. So within this assignment, it makes that distinction between cladding, which is like the external skin for either cladding for the roof or cladding for the walls, and structure. in some scenarios that can be the same thing. So for solid masonry construction, our structure is also our cladding. So when we use cavity brick construction or even double brick construction, that is both our cladding and our structure. I'm not sure if it's there anymore. Is there? I'll just have a quick look out the window here. I think it's been taken away. So up until recently, there was a building down here manufactured from really like thick sections of plywood. Did anybody see that building at all? No. So that's
down in the carpentry area.
Has it been moved? It might be
Like
moved.
in the actual carpentry section.
Right. Yeah.
If you did, I think I saw that.
Yeah.
It's really like the small scale of the house, essentially.
It was, yeah.
Yeah,
And it had some fixings on it for harnesses and whatnot. That type of construction there is known as CLT, or cross-laminated timber. It's something that has, I guess, there's been a few buildings built with it overseas, particularly in the UK. They've built some high-rises with this cross-laminated timber. It is essentially large sections of plywood, like really big, thick pieces of plywood that they manufacture within the factory and then put it all together on site. That creates both the cladding and the structure of the building. There are issues. There was a building built in Melbourne using CLT, but the company that produced CLT and have tried bringing it into Australia have had some issues with that, because it's basically around the timber supply, and the properties of timber that we grow here differ from the density of the timber that they grow in Europe, and it's about being able to maintain that strength, which they can't do with the product in Australia. However, you can still propose something like that if you wish for this building, and I suggest researching CLT if you've got a chance, because I think it's still a technology which has legs when those issues are resolved. But yeah, if you were to choose CLT, that is also both the structure and the cladding, and so you can talk about that in your structural component. You can also talk about the same product in your cladding component. If you were, yeah.
There's also a product that has cement sheet with a filler and a cement sheet.
Right. Okay.
That is an external and internal wall cladding, but it's a frame as well.
Is that called mag wall?
I can't actually remember. No, I can't.
Yeah. No, it's not. No, it's not. Although it's not mag wall.
It's made in Queensland.
Right. Okay. Yeah. I don't know that one. Well, I don't think I know that one. If you find out, let us know, because it's great to grab these things and pull them into the class, because there's new stuff being designed all the time and being assessed and being available for use in the construction industry in Australia all the time. So these emerging technologies are great. If you were to use a material or an approach or a structural system that is also a cladding system, or let's say tilt-up concrete. Tilt-up concrete is also structure and cladding. Do your detail of that material within the structural component, and then when it comes time to talking about that in your cladding component, rather than repeat yourself over and over when it comes to cladding, say, refer to earlier on in the report where you've covered those details and address the aspects of the material more pertinent to the cladding only in the cladding section. Does that make sense? So when it comes to cladding, rather than repeat yourself, just refer to things written earlier in the report.
We grabbing research and putting it into our own work, or we doing our own words to do it?
By and large, do your own words. So provide a summary of your research. So typically, when you research and you get this product information, all of that information there is designed essentially, I guess, for trying to sell the product. What we don't want so much within a report is a lot of the language that goes around trying to sell a product. We don't want all the emotive language, etc., that you might find in the product literature. Basically, grab all of the technical information and all of the information specifically required by the assessment literature, and get that in. So get that in your own words. But if there are phrases within all the product literature that are fantastic for what you want to include in your report, include it in italics and then reference that. So say, I've grabbed this from their site because that explains things really well. So basically do whatever works well for the report. So we're to provide 3 options for roof structure, 3 options for wall structure, and 3 options for floor structure. In some instances, they can be the same. So we can have, for example, roof structure, we can have cold rolled steel framing. We can, you've got various different manufacturers, cold rolled steel framing. We can also use that same steel framing for our walls and that same steel framing for our suspended floors. So we can be doubling up there. And once again, if we're doubling up within those categories, provide a lot of information there in roof, and then if some of the information is doubling up, just say see above, and then refer just to the stuff specific for walls. So 3 structural systems for each. So I start my report. So we go to our report, and then I will provide a report summary. So I'll say, this is what my report contains. And that should be a relatively short statement saying the client has employed me to re-envisage this design, and then include a diagram of the design, so figure 1, as a permanent structure. Within the report, I will provide 3 structural options for each component, 3 cladding options for each component, and 2 options for hot water systems. So we put that in our summary. It says this is what the report's going to contain, and then from there, if you want to, you can do a contents. So you do a contents, and then we'll have probably page 1. We'll have roof structure. Page 1 still probably have wall structure, and then floor structure. So roof structure, wall structure, floor structure, and then within that roof, walls and floor structure, we'll have roof structure option 1, roof structure option 2, roof structure option 3, and then that might be page 1, and then we're getting on to page 2 down here, etc. as we go through. And then we will go further in our contents. Then we'll say cladding system 1, cladding system 2, cladding system 3, or cladding system roof option 1, option 2, option 3, cladding system for the walls option 1, 2, and 3, and then we don't have to do cladding for floors, obviously. So we can provide a contents page, and I think it's always good to provide a contents page within a report, but it's not necessary. What is necessary within a report, though, is a clearly defined, basically dot point approach to our report. So we will say, so we'll have our summary, our contents, and then our first section is going to be roof structure. So that is our heading. Then under roof structure, we'll have subheadings. So we'll have roof structure option 1. Option 1, and let's say that will be timber trusses. Yeah, and please excuse my text, I'm just trying to get through this nice and quickly. So that's option 1. Then for each system, you're asked to consider the following: aesthetic properties, maintenance requirements, fire resistant properties, coatings, etc. So we'll go main heading, roof structure, subheading, roof structure, and then we'll have dot points in bold, aesthetic properties. And then we'll talk about the aesthetic properties of a timber truss roof. Now there may not, so for timber truss roof, there may not be much to mention there. You can say, typically with a timber truss roof, all of the structural components are concealed above ceiling linings and beneath roof claddings and are not visible. It can, in some scenarios, be designed so that the timber trusses are featured within the building with a raked ceiling, for example, and they're on display. If you were to do that let's say, as featured trusses, then you may want to have attractive nail plates and attractive finishes on your timber, for example. But there's not a lot to add there. And then we'd have another dot point, maintenance requirements. And then something simple to say about maintenance requirements, fire resistance properties, etc. So you can see where I'm heading in terms of my structure. I've got my heading, subheading, and then dot points for each. And so these dot points are provided for you in the assignment literature. You can grab that, copy, paste into your Word document for starting to create that skeleton or that structure for your report. And then it says, for each system, consider the following. Some of these are not going to be applicable. And then you can still include that as a dot point, but then you can say not applicable to the product or to the technology. But at least that way it shows you have actually considered that within your report. So we'll do that. So we'll have roof structure, subheading, dot points, and then we'll have subheading again, and then we'll go to cold rolled steel frame trusses, for example. And then, so for each main heading, we'll have 3 subheadings. And then the cold rolled steel roof trusses will have the same dot points. Once again, grabbed from there. So it looks like a lot. Oh yes.
So each option is essentially one product.
Yes. Yep. Yeah. So yeah, one product or structural option. So because there are like half a dozen steel. Yes.
Okay.
Yeah. So for roof, we've got 3 structural options for that. So pick 3 products or 3 approaches for that. For walls, we've got 3 structural options for that. Pick 3 for that. Yeah. And so we go through and we create the structure of our report like that, and then go on and do the research and fill in all the gaps. Once you do that, it should be fairly well. It's not simple. That's where the work starts. But once you have that guideline there and that checklist of what you need to research, it makes the research much quicker and easier. Another aspect about reports, and I sort of touched on this earlier, it's not at all about flowery language. It's not about creating a story or selling a product. It is simply talking about the pros and cons and conveying the information as precisely and concisely as you can. So we give you the information for you to make up your mind. So it's being presented to a client. I'm essentially the client. But what I do not want is a story or any superfluous literature. I want only the information that enables me to make the choice or weigh up those various different options. Does that make a lot of sense? Yeah. So our assignment 1, well, our assignment 2 and our assignment 3, with all those assignments, they're the same type of thing. So with this first assignment, that's where you get to, I guess, cut your teeth on the production of a report like this, and I'll give you a lot of feedback from your first report about how you can go approaching your next 2 reports in a much better fashion. So this is, in a sense, a trial run, but if you get it right on your first one, it just makes it so much quicker and easier for the others. So we have it at the due date of the 30th, and that's at 5 o'clock. So it's on that Friday, at 5 o'clock. Submissions for this assignment are to be in PDF form. So once you've finished your assignment, you're happy with it and have proofread it, print it to PDF and upload it to Moodle. There's a section in Moodle there for uploading your assignments. So we'll have a look at that in a minute. And upload it as a PDF. If you don't upload it as a PDF, I'm not going to fail you, and I probably won't, harass you to upload it in another format. The only reason I specifically asked for PDF is because sometimes there are issues with compatibility between the programs that I've got on my computer at home and what you guys are using at home, and it can throw formats out and all sorts of stuff and make it very difficult to read. In the odd instance, if you have to produce it as a PDF and I can't open it up on my computer, I'll ask you to resubmit as a PDF. But to keep things simple, get it in as a PDF initially. So we do the same thing for cladding. So we've got our checklist of things here for structure. So aesthetic properties, maintenance requirements. Maintenance requirements, fire resistance properties, coatings required, fixings required, compatibility interaction with other elements. Many of these things will be very new to you at this point, and if we get the structure of our report and we start filling in those gaps, we can do this over the next couple of weeks as many of these things are introduced as well. So fill out what you can for the time being, but things like compatibility and interaction with other elements, that may have to do with the differential metals, with cathodic and anodic properties of metals. Does anybody know what I mean when I say cathode or anode?
Yep. Basically, same as the easiest example is a ship. You don't have just one earthing point because it'll actually cause corrosion at one point.
Yep.
And they'll have also on the boat what they call sacrificial anodes. So they're attachments to a ship where all the corrosion will go to one point. They can just undo it, put enough bits on, and it saves the actual hull.
It's in hot water services too.
Yeah, got them in hot water services. Yeah, we put them on tanks we build as well, sacrificial anodes. So the steel shell of the tank we build, it's a mild steel basically, but then we put on a magnesium bar that's attached by a wire. Magnesium is a far more reactive metal than mild steel. So when the two are joined together, all of your free electrons in your magnesium grab onto oxygen, and then that takes free electrons from your mild steel, and so your mild steel doesn't have any free electrons anymore to bond with oxygen, because that's what rusting is. It's the bonding between steel and oxygen, or any metal and oxygen, that causes rust. And so we attach via a wire a more reactive metal, and that does the rusting for us. And then in 5 years' time, we can get rid of those sacrificial anodes and put new ones on. So we're not replacing the tank or the hot water service or the boat, or you've got those in boat engines as well, sacrificial anodes that bolt on. And so compatibility interaction with other elements. So if you've got, let's say, you've got copper cladding, you've got an unlimited budget for a building, you've got copper cladding on a mild steel frame, you're going to have some cathodic and anodic reactions there between your cladding and your frame, for example. Compatibility interaction with other elements may also relate to, let's say, like a completely impervious sheeting, or like let's say non-breathable sarking with a timber frame. The non-breathable sarking doesn't allow any moisture to escape, and if used in conjunction with a timber frame, you can get the harbouring of moisture in an area where you've got the presence of food for fungi. So cellulose in timber is like it's a hydrocarbon. Fungi like to eat hydrocarbons. When in the presence of moisture, you can get some mold growth in there. So that's, so when we talk about compatibility interaction with other elements, it's when you bring several building components together, you can get these unintended consequences. Health and safety issues, well, that's generally specific to the material. So we all know asbestos, certain health and safety issues with asbestos, and hence we don't use it. But I guess lesser known, MDF, medium density fiberboard, there are issues. What's that?
That's the next asbestos.
Yes, yeah, I've heard people refer to, several people refer to that as the next asbestos. It's, tiny little fibres, when you're cutting it, you've got to really, wear masks, etc. Or even hardwoods. People get lung cancer who have worked with hardwoods a lot from breathing in the dust and things like that. So we've got some health and safety issues in working with the materials. Concrete, for example, the heat that's given off from concrete or the drying effect on your hands of cement powder, etc. Durability, that's fairly self-explanatory. And compliance requirements. So what is the relevant Australian standard is a great place to start when you talk about compliance requirements. And is it mentioned anywhere in the National Construction Code? So 99.9% of cases it will be in the National Construction Code. If it's not in the National Construction Code, then there's a definite compliance requirement. If there's not any mention of it, so let's say straw bale as a structure, it's possible, but there is not an area within the National Construction Code or any applicable Australian standards that refer to straw bale as a structure. We can only use straw bale as a structure if it does have engineer's certification, because it doesn't meet those requirements. And so its non-existence within the NCC or Australian standards is a compliance requirement that needs mentioning. So that's our dot points there. Are there any questions about those particular headings, particularly the ones I didn't cover at the start?
So the companies are going to have all the information for it?
Predominantly yes. Some of it you're going to have to think outside the box a little bit for. Yeah.
For the most part, when we go and find a product, it will have pretty much everything.
Yes, certainly if a company sells it, by and large, they have addressed all the compliance requirements, and it will be covered by it will be, will have an Australian standard attached to it, so they will have had it assessed as per the Australian standard. I guess the important thing to look for in product literature is what they don't mention. So they will want to tell you all the good stuff about it. So they'll say, blue board looks fantastic. Well, I guess that's a bit subjective there. The maintenance requirements are low. Unless your house is in a reactive site where you get gaps opening up between your blueboard sheets and the cracking in your render there, then the maintenance, So look for what they don't mention and think about what is not mentioned in the product literature, because the product literature wants to sell the products to people. One, I guess it's a relatively infamous example of that now is aluminium cladding. Did anybody see, I think it was a Four Corners documentary on aluminium sandwich panel cladding in high-rise buildings? Later on in the subject, I'll see if I can grab that video. I think it's up on YouTube now. It's an excellent bit of an eye-opener to watch. But everybody heard about the Grenfell Tower disaster in London. So a large high-rise building that was clad entirely with aluminium sandwich panel cladding, which is a very thin layer of aluminium and then about 3 millimetres of polyethylene filling. So polyethylene is a hydrocarbon. It's flammable. It's not highly flammable until it gets hot. When it gets hot, it starts off-gassing, becomes flammable, and then you've got another sheet of aluminium. Once again, like let's say it's like 0.6 millimeters. So the whole thing is about 4 millimeters thick. This sandwich panel, you can have the outside anodized. It can look fantastic. You can put just about whatever color you want on it, and you'll see buildings about. In fact, I think there's some aluminium sandwich panel clad sections within this area here. Have a look for that yourself, but possibly in a later class we'll go for a wander and have a look at some other materials. So this aluminium sandwich panel cladding was used as a cladding for the whole external section of a building, which is fine until you get a point of like some flame happening here, like from an it's from a fridge, I think in the Grenfell Tower. So a fridge, something went wrong with it. It started a small fire. If that fire is hot enough to get this polyethylene filling going, then this panel starts burning and flaking off, and it gets all the other panels burning all the way up the building until you've got sort of bits of aluminium with polyethylene dropping to the ground and igniting fires elsewhere, etc. Can't remember why did I start talking about the sandwich panel cladding? What's that? Health and safety. Yeah. And so with your manufacturers of the various manufacturers of your aluminium sandwich panel cladding, they're not going to want to talk about that. In their initial product literature, they will say, it is fire resistant, which it is. It is fire resistant up until a point, up until you really get it going. Once you get it going, then it keeps continuing. So they will not want to make a mention of that, and still the manufacturers of aluminium sandwich panel cladding for sale in Australia, they talk about its fire resistance capabilities, and they've done a lot of work on that, admittedly since this disaster. But still, they will want to downplay that. Our role as building designers, architects, specifiers is to really understand that product and make some recommendations and see what's not in literature as well. So it can be helpful to read between the lines a bit and see what's not included in the product literature. Beyond that, it should be relatively self-explanatory. Actually, no, I'll just quickly cover the hot water services as well. So we have the section at the end. So toward the end of our report, it says compare the advantages and disadvantages of different hot water services. Make a recommendation to your client based on your research. Within this recommendation, identify relevant Australian standards and make note of important aspects of installation methods, initial estimated costs, and ongoing costs. So these initial estimated costs, I've included the word estimated because it is typically difficult to get the actual cost of a unit. You have to do a decent amount of contact with the suppliers to get your costs on that. To get just an idea of the cost, and certainly an idea of the initial cost in comparison to other units, is important. And so those initial costs and those ongoing costs. For example, an electric storage hot water service is actually relatively cheap to buy. So they're a fairly cheap unit to buy, but because they are so energy hungry and energy hungry for electricity, they're expensive to run into the future. So your initial estimated costs are low, but your ongoing costs are high. You can compare that with a electric boost evacuated tube solar hot water storage unit that will be expensive to buy initially because you've got to buy the tank, you've got to buy the evacuated tube solar component from on the roof. So it's going to be expensive initially, but cheap to run in years to come, and that cost will be offset in sort of 6 or 7 years or so. To help with that component, there is a link on Moodle.
Does it tell us somewhere how many residents are going to possibly be living in this house? Because that needs to be factored into that sort of thing too.
Yeah, that you can imply yourself. So you can specify that. So we look at the building, we go, okay, this is the size of the building. I think we're under 100, we're about 105 square metres or something for this building. It is a very small building. What's that? Yeah, two bedroom. You know, yes, quite possible you have a master bedroom with 2 parents and then 2 bunk beds in the spare room, total of 6 occupants, but it's getting a bit squeezy. You know, yes, you can say for the purposes of this report, we have assumed, 4 occupants for the building, or 3 occupants for the building, or whatever number you wish, but keep it reasonable. So further down in residential, we have a link here. We'll have several. We've got hot water systems presentation. We'll be going through that in a couple of weeks' time. But if you want to get into that, if you're getting up to doing hot water systems in your report, jump in and have a look at that early. There's also a link here to research different types of hot water systems through this link to understand the difference between gas and electrical and gain some insight there. But this link here, the hot water savings, so it's a link to a calculator to compare the running costs of different hot water services. So that can provide you with some comparison of our initial costs and then the ongoing costs of the various different hot water systems. And then underneath here, which system is the cheapest to run? What type of system would you choose for Task 1 house? Include the reasons for your choice and image of the system at the end of your report. So you have to compare several systems, but in the end, you can make a recommendation to your client about what you think is the best system, or even several recommendations. You can say, if you intend to be using this house in an ongoing basis, this may be the best system for you. If you intend for it to be a rental, this may be the best system for you. If you intend, or if you have an inclination toward low energy usage and conservation of the environment, this might be the best system for you, despite the initial outlay in cost. So that's Task 1. Are there any questions?
Is it graded or is it just pass or fail?
It is just pass or fail.
Yep.
Yep. Yeah.
And do we have drafted by you?
No. So if you want, you can hand it up early, and I can have a look over it and say, these are some points you can address. But also, being the first assignment fairly early in the subject, you can hand it up, and then I can say, these are some areas you need to address, and I'll give you the option of resubmitting that assignment. And we've got a bit of time to do that because we're at the start. Obviously, the most time efficient way is if you can get it in as a draft early. So you knock it together, get it in, think, it's pretty good. I'll get it in as a draft tonight, and I'll have a look at it and tell you about that before it's actually due. That pushes, safe.
Would you have to do it because if it's pass and fail, and you look at it and go, it's acceptable, and just leave it at that, or do you put in the points that you mentioned that you can evaluate on?
Yeah, look, if it's acceptable, I'll tell you it's acceptable, and you can choose to do that if you wish. Because once you've met the criteria about what's required, that is all that is required. But you can also use this as an opportunity as an opportunity for learning beyond just the basic requirements of the pass and fail. Because obviously, when you finish up here, you're competing with everybody else and if you've just gone for pass or fail when it comes to interview or work situations, that sort of thing can show up. So, close it down. So that's assignment 1. Now, one thing, this relates to last week's class, consultants and authorities. I didn't show you this last week, did I? So yeah, I think we got to having about 7 minutes or something right at the end there. So this should I guess essentially fits into last week's class fairly well, but it's a summary, or it's a quick discussion of the BCA. So it's still referred to as the BCA, not the National Construction Code, but it's a document. So it's within the residential section, gives you a link to Australian Building Codes board.gov.au, where you can produce your own login and get free access to the National Construction Code. This we pretty much covered in last week's lecture, but if you want to refresh it, go through this and have a read. So we talked about this, Volume 1, Class 2 to 9 buildings, Volume 2, Class 1 and 10 buildings, so residential, commercial. That we covered last week. Gives you a bit of an introduction to the volumes. So here shows the contents, so the general requirements, application, interpretation, acceptance of design, construction, classification. So that's where we talk about whether it's Class 1, Class 2, Class 3 buildings, etc. And the various different performance provisions for each section. So structure refers to various different structural approaches and the relevant Australian standards. Damp and waterproofing, so a major component of building design. Fire safety, so it talks predominantly about, that's volume 2, so it's fire safety, predominantly about fire separation and required fire resistance levels. Health and amenities, so what are the basic requirements for light, ventilation, etc. Safe movement and access, covers things like stairways and disabled access and facilities. Energy efficiency, so it covers the relevant Australian standards for designing in an energy efficient manner. Also, what insulation is required per climate zone, and etc. etc. So this is just an excerpt from the National Construction Code. So go through that at your own leisure. And we covered this last week. Performance requirement means a requirement which states the level of performance. So performance solution or deemed to satisfy solution. So they are our two approaches. So performance solution can be assessed by the relevant engineer. A deemed to satisfy solution is in reference to the Australian standards and the National Construction Code. So roll through this within your own time at home if you wish. But I wanted to get to this last page because that includes the link and the login for the Australian standards for our access through the TAFE. So at the end of that document, you've got a hyperlink here. It will take you straight to the right location, and then your login is that number, and your password is that number, or that password. And then put in your surname and /Tonsley.
Are you able to just download it from that through?
Download the Australian standards? Yes, yeah. So use that link for downloading your Australian standards. And also those Australian standards in some formats time out. So if you go on and download them, you may find you go to refer to them in a week's time and they'll say this is timed out. You can, if you want to keep some things for ongoing reference, I think you can print it as a PDF in say various formats, and then you can
Can you
use
leave that
those
up for a sec?
to revert. What's that?
Can you leave that up for a sec?
Yeah, for sure.
Yeah, thank you.
Yep, but that's available through the Moodle, and it's got the link to the website there. I encourage you to go into that under that BCA tab in Moodle. Click that hyperlink that'll take you to the right page and save that as a favourite. So we'll save that link somewhere else, so you don't have to keep going into Moodle to find it. You've got that within your search engine on your computer, and then save that login information or write that down. Keep that somewhere. Also, an important thing to note is to use the SAI global site there for finding Australian standards. Put AS in front of something as well. So let's say we're going to search for the timber framing code 1684. If I just put in 1684, it's not very reliable in pulling up the timber framing code. But if I put AS in front of that, then it is. So always put AS in front of whatever Australian standard you're searching, and your results will be far more reliable. So is everybody finished with that? Not waiting on anyone? Right, close that one down. So that's in here, so just down below task 1, BCA and Australian standards. Also yet another link on how to reference that spot, and we covered that last week. Okay, so we'll get stuck into timber framing for our last hour and a half. Okay, what I'll start with this one here, the PowerPoint provided by Wood Solutions. Timber framing. Take a little while to open. This is the most comprehensive of all the resources up there. We do have a few other things within those other resources to go through. We'll go through those coming weeks. So, residential timber frame construction. By and large, any of the timber framing you are going to design is going to be in accordance with this Australian standard. So, Australian Standard 1684, and you should be using the current 2010 edition. So that's our current edition there. But that timber framing code has its limitations. Provides the building industry with procedures that can be used to determine building practice to design or check construction details, determine member sizes and bracing and fixing requirements for timber frame construction in non-cyclonic areas with wind speeds from N1 to N4. So does everybody know what I mean when I say wind speeds now? So we covered that last week. Typically, you're going to deal with wind speeds of N1, N2 and N3. If you buy a hard copy of the Australian Standard, it will come with a CD of span tables. That, I guess, to purchase any Australian Standard, they're relatively expensive, but if you have more money than time, grabbing a hard copy, purchasing a hard copy with that CD certainly saves you a lot of time, because within SAI Global, to get those span tables, you have to download those span tables individually, and that can take quite a while to do that, to go through all that methodically, and having the CD can save you a lot of time. Those span tables are provided for all the different strengths of timber for the different wind scenarios. So you'll have a timber span table. By and large, the most common span tables, 7 span tables you'll ever refer to are for MGP10. So MGP10, that relates to machine graded pine, and the 10 is its stress grading for the machine grading. The reason you refer to that typically is because that's what we produce a lot of here in South Australia. Down in the southeast, the radiata pine that's produced is typically either MGP 10 or MGP 12. And that's what the bulk of our framing is. Within that, so within MGP 10, we will have a timber span table for N1 and N2. So for the two lower wind speeds, we'll have a span table. And then for N3, we'll have an MGP 10 span table. That span table will include everything from our bottom plates, studs, noggins, top plates, rafters, ceiling joists, roof battens, lintels, and probably you've got pitching beam, hanging beams, etc., and purlins, strutting beams, all that sort of stuff. They're all listed within that span table, and so and things like veranda beams, etc. So you can go, I have to design a lintel for over this window in this wall. I'm going to do it out at MGP 10, and you work through that table to say I've got this amount of roof acting upon that lintel. The lintel needs to be of this size, and I'll show you those span tables in a minute. So the really common span tables you'll need, so certainly MGP 10 and possibly MGP 12, but typically what is done is you specify it as MGP 10, and the timber supplier may have MGP 12 and they'll supply MGP 12 and it's used in place of MGP 10, but typically you just specify it as MGP 10 unless you're on the edge of what's suitable. Then you like, so let's say a 9x45 MGP 12 will do it, but 9x45 MGP 10 won't. Then you specify as 12, but typically just specify everything as MGP 10, and the builders can use what they want. So you'll be using that one. You'll be using seasoned softwood F7 a lot, because for a lot of your external timbers, so for all of your veranda beams, pergola constructions, fascias, barge boards, and I'm just listing off these names of timbers that some of you may or may not know yet, but all those timbers that are going to see weather, they have to be sealed with LOSP, which is light organic solvent protection. Typically, F7 timber is used for LOSP coating, and so you're going to have to have seasoned softwood F7 span table handy, and then you probably want to have F17 and F27 hardwood span tables as well. So they will relate to your tile battens. So typically you'll use hardwood battens for tiling, or you'll specify hardwoods for larger spans where you want smaller members associated. So they're the typical ones you want. Yeah. But if you can grab the whole lot, grab the whole lot.
Just the CD.
I don't know. I haven't bought it in a long time. Yeah, because I bought it back when I studied in 2007. I think it was over $100 then. But yeah, look, that's 11 years ago now. And in the office where I worked, they had all the PDFs of all the span tables in the library, which is a very easy way to go about it, because when you've got it as a library there, you just go down and you go, oh yes, I want F17 seasoned softwood. Click on it, and it's open in front of you rather than flicking through. So yeah, so the PDFs could be handy there as opposed to hard copy. So that is an example of a span table. So it's over in that room there. Actually, if you excuse me just for a minute, I'll go and grab the roof from over in the room, over there. They're not using it there, and then we'll have a bit of a gather around the roof and have a chat about that. If anybody wants to have a quick toilet break or so, we'll resume in about 2 minutes. While I grab that.
So I'm in here